Let's try a limiting reactant problem or limiting reagent problem. The problems up until now have included a phrase like with excess oxygen or in excess silver nitrate. That's telling you that there is plenty of that substance for the reaction to occur. In this particular instance, we don't see that phrase here. Instead, we are given quantities of each of our reactants. We don't know which one is in excess. Your limiting reactant is the one that limits the amount of product formed. The other one will be in excess. It is really important to note that when you are identifying the limiting reactant, it is not just a simple matter of which one is present in the smaller amount. You have to consider how the reaction occurs. You have to consider the stoichiometry of the reaction. Remember that our reaction is always written in terms of ratios of particles. So we could read this as 2 atoms of copper react with 1 atom of sulfur to produce 1 molecule of copper sulfide. But we can also read this in terms of moles. 2 moles of copper react with 1 mole of sulfur to produce 1 mole of copper sulfide. We cannot interpret this in grams. So first, let's establish our relationships between each of our reactant and our product. Off to the side here. We know that for every 2 moles of copper that react, that's going to produce 1 mole of copper sulfide. We also know that for every 1 mole of sulfur that reacts, that's going to produce 1 mole of copper sulfide. We are given quantities in grams. So let's first use our molar masses to convert our grams into moles. So let's just make a list of molar masses off to the side here. Remember that we get these from the periodic table. Copper's molar mass is 63.55 grams per mole. Sulfur's is 32.07 grams per mole. And copper sulfide's is 159.2 grams per mole. So let's use those molar masses to convert each of my quantities into moles. We know that for every 63.55 grams of copper I have, that corresponds to 1 mole of copper. We're going to do the same thing for my sulfur. We're going to figure out how many moles that 25 grams is. And when we plug those into our calculators, we find that we have 1.259 moles of copper and 0.7795 moles of sulfur. It's important to note that we haven't changed anything about how we use molar mass. The coefficients in front of my the coefficients in my balanced chemical equation have no influence on my molar masses. If you're struggling with using molar masses, take a look back in chapter 3. Okay. So now I know how many moles of each of my reactants I have. Now I can use my mole ratios. To figure out how much product I can make with each of these amounts of starting materials. We want to know how many moles of copper sulfide can I make with 1.259 moles of copper, assuming that I have enough sulfur to do that. My mole ratio, for every 2 moles of copper that react, that's going to produce 1 mole of copper sulfide. So with 1.259 moles of copper, I could make about 0.6 moles of copper sulfide. But that's assuming that I have enough sulfur. My problem doesn't tell me whether or not I have enough sulfur. So we're going to figure out if I have enough sulfur by asking the same question from the opposite perspective. I'm going to ask how many moles of copper sulfide can I make with this much sulfur? Assuming that I have enough copper to do that. So I'm going to use that mole ratio, knowing that for every 1 mole of sulfur that reacts, it's going to produce 1 mole of copper sulfide. So I have enough sulfur to make almost 0.0 moles of copper sulfide, assuming that I have enough copper to do that. But if I look at my copper, I only have enough copper to make 0.6 moles of copper sulfide. So I am going to run out of my copper first. My copper is my limiting reactant because I run out of it first. I have enough sulfur to make 0.7795 moles of copper sulfide, but I don't have enough copper to make that much copper sulfide. I only have enough copper to make 0.6295 moles of copper sulfide. So my copper is my limiting reactant. Let's continue this problem by saying, if 87.4 grams of copper sulfide are produced, what is the percent yield? So our percent yield is always going to be our actual yield divided by your ideal yield times 100 to give you a percentage. Keep in mind that an ideal yield and a theoretical yield are the same thing. So this 87.4 grams of copper sulfide is my actual yield. That is how much I actually made from this reaction. So let's go ahead and plug that value in. Making sure you keep track of your units and your substance labels. Your ideal yield or your theoretical yield is going to be how much you are expecting to get out of this reaction. If we take a look back, okay, we are expecting to get 0.6295 moles of copper sulfide out of this. This is our ideal yield in moles. Again, your ideal yield is the same thing as your theoretical yield. Those are just synonyms. Okay. So my ideal yield here, we found it in moles. We want to make sure that we have it in grams in order to compare it appropriately to our actual yield. So on this next page, off to the side, okay, we're just going to figure out how many grams of copper sulfide that 0.6295 moles of copper sulfide is with our molar mass. When we multiply those, we find that our ideal yield in grams is 100.2164 grams. This is my ideal yield in grams. So nothing has changed between these two values except for the unit that it's in. Now that we have our ideal yield in terms of grams, now we can compare our ideal yield to our actual yield. Remembering that we're going to carry at least one extra digit through here. Notice that my units cancel. Grams of copper sulfide. So I'm left with something unitless in order for me to have a percentage. And when you solve that, you get a percent yield of 87.2%. And that's how you solve a limiting reactant problem. Keep in mind that your limiting reactant is the reactant that runs out first and determines your ideal yield.